I'm Dr. Chris Creighton, and in this video we'll be talking about multiplying radicals. The core of this one is performing radical algebra, and particularly multiplying. And again, much like adding and subtracting, we'll have to do a lot of simplifying radicals when we multiply them. So when can we multiply radicals? And let's look at a couple cases. So what about the square root of 2 times the square root of 3? Well, we know by properties of radicals, this is equal to 2 times 3 square rooted, which is equal to the square root of 6. So we can multiply in that case. And the thing to note here is that we have the same index. So you essentially do need the same index to multiply if the radicands, the 2 and the 3, are different. Well, what about the square root of 2 times the cube root of 3? Well, unfortunately, this one is fully simplified, so that we can't actually combine these two. They have different indexes, and the bases of the radicands 2 and 3 are different. So this one is simplified. And then going back to some of the stuff we've talked about earlier, if we have the square root of 2 times the cube root of 2, so different indexes but same base, recall that we can write this as 2 to the 1/2 times 2 to the 1/3, which is equal to 2 to the 5 over 6, because we put a common denominator. This 1/2 turns into a 3 over 6, and the 1/3 turns into a 2 over 6, which gives us a 5 over 6. So this one has same radicand. But the core one we're going to be focusing on today is this first one here, when we have the same index. So say they're all the square roots or they're all the cube roots. That is the case we're going to be dealing with the most. So let's do a couple examples by doing the indicated operation. So the first one, I'm going to do root 7 times 3 plus the square root of 2. So now in this case here, the first thing I notice is that there's some distribution going on. So I need to multiply the 7 times 3 and the 7 times 2. So this is equal to 3 root 7 plus root 7 times root 2. So like we discussed, these have the same index. They're both square roots, so we can combine those two. So this is equal to the cube root of 7, or 3 times the square root of 7, plus the square root of 14. And this is fully simplified. So we are done. All right, you cannot combine a square root of 7 and then the square root of 14. Square root of 14 is simplified, and the square root of 7 is simplified. There are many of these problems that you may need to do that with. 2. Let's try the square root of 3 plus 1 times the square root of 7 plus 5. So with this one here, this is just like polynomial multiplication. Like if the root 3 was an x and the root 7 was a y, you'd multiply it the same way. So in this case here, we get a root 3 times a root 7 plus root 7 plus 5 root 3 plus 5. So that's it, just fully expanded out. We have all 4 of the terms there. Now combining, these first two here, the root 3 and the root 7, combine to be the square root of 21. Now that term is fully simplified. Then we get a plus the square root of 7 plus a 5 square root of 3 plus 5. This is now fully simplified. Because you can't simplify the square root of 21. You've pulled out all the squares inside of the radical. Now root 7 and root 3 also cannot be combined, particularly with that root 5. So this is the best we can do for this problem. Now let's do one more. So let's do the square root of 2 minus the square root of 3 times the square root of 2 plus the square root of 3. So fully multiplying this out, we get root 2 times root 2 minus root 3 times root 2 plus root 3 times root 2. Well, that's nice because we have the plus and minus there. Plus root 3 times root 3. Now, the second one over here is minus, so actually this is going to be a negative right there. Simplifying this down, this is the root 2 squared plus 0 because we have the negative root 3 times root 2 plus root 3 minus root 2. Then we get minus the square root of 3 squared, which is equal to 2 minus 3, which is equal to negative 1. So this one's fully simplified down. And this worked out super nicely because if you notice, this is the difference of squares. So the difference of squares is of the form if you have something minus something times something plus something, so like a minus b times an a plus b, this fully works out to a squared minus b squared. So in this case here, a is the square root of 2, b is the square root of 3. Square root of 2 squared is 2, square root of 3 squared is 3. So it's worked out to 2 minus 3, which is negative 1. 4. Let's try to do 1 plus the square root of 3, quantity squared. I just want to warn you that this is in fact equal to 1 plus the square root of 3 times 1 plus the square root of 3 again. You do not just square 1 and square the root 3. You have to distribute. So in this case here, this is equal to 1 plus root 3 plus another root 3 plus root 3 squared. So I'm going to write that as a squared there because I'm multiplying root 3 times root 3. So this is now equal to 1 plus 2 root 3, because those are like radicals, so we can add them, plus 3. So that's equal to 4 plus 2 root 3. It's quite nice. And then 5. We have 3 square root of x plus root 5 times 7 square root of x minus 2 root 5. So this one looks like it's going to be a bit more, but that's completely fine. It happens. Again, just imagine these like polynomials. This is just polynomial multiplication, but instead of like x and a y, or x squared and x cubed, or y squared, this is just radicals, so like this cube root of x, for instance. So in this case here, this is going to be equal to 3 times the square root of x times 7 root x. Then we get plus square root of 5 times 7 root x minus 2 root 5 times 3 root x, and we get minus 2 square root of 5 squared. So this simplifies down to 21x, because we have the square root of x times the square root of x. Here we get a plus a 7 square root of 5x. Here we get a minus 6 square root of 5x. And we get minus 2 times 5 square root of 5 squared, which is 2 times 5, which is minus the 10. So this fully simplifies down to 221x minus 10 plus the square root of 5x. This is now fully simplified. Again, this behaves just like polynomials, except you know what some things are when they're squared.